Hi students, so now let's do this next question. Okay, this is also in this question here you are asked to find the Norton's equivalent, and here also you can see that this circuit also has a dependent source, right? This is a dependent current source, right? Look over, it is 5I, and what is I? I is the current through this branch. So we have a dependent current source, which means you can neither short it or you can neither open it, or you can't do anything with it. So the only way of finding ZTH in this circuit is by finding both the Thevenin's voltage and then the Norton's current, and then taking its ratio. Okay, that's the only way of finding ZTH if there is a dependent source over here. The rest of the method is the same. So first I will find VTH. So what is VTH? VTH is the open voltage across A and B, right? This is VTH. Okay, so in that case, by applying mesh analysis, let this be I1. Okay, let this be I1, and this is I2, but I'm not going to mark it because this is not a mesh. But I2 is equal to 0. I will write that much for you. I2 is equal to 0. I2 is equal to 0, and here this is I3. Okay, alright. Okay, so now I'm going to write the equation for mesh 1. Equation for mesh 1. So here this I1 is touching only these two elements, right? That is 100 plus 10J. There you go. Okay, 100 plus 10J, and that's it, right? And what about I2? I2 is touching only this element, and that is 10J, and that's it, right? The I3 is not touching any element of mesh 1, right? So there's no I3 in this equation. This is equal to, and this I1 is coming out from this positive terminal, so it is equal to 10. 10 angle 0 is 10. Okay, but I2 is equal to 0, so you can remove this equation also. So therefore I1 is equal to 10 by 100 plus 10J. Okay, 10 by 100 plus 10J. 10 divided by 100 plus 10J. Okay, and you get is 0.099 minus 0.01J. This is the value of I1. Okay, so now I found the value of I1. And what about I3? I3, here you can say, of course, the equation for I forgot to write the equation of I. The equation of I is equal to I1, right? Because I1 is the current through this branch, so therefore I is equal to I1 is the equation, right? So what is the equation for mesh 2? Or equation for VTH. First I'll write the equation for mesh 3. Okay, let me write the equation for mesh 3. I hope you already know why I'm writing the equation for mesh 3 first instead of mesh 2. Why I'm writing is because you look at this equation over here. This I3 is here, there's already a current source over here, right? And the name of that current source is 5I. 5I is the name of this current source, and also there's a current I3 flowing in the opposite direction, which means therefore the equation for mesh 3 is I3 is equal to minus 5I. This is the equation, minus 5I, or in other words this is equal to minus 5, since I is equal to I1, minus 5I1. I1 I have already found, it is minus 5 into 0.099 minus 0.01J. So therefore I3 is equal to minus 5. So this answer that you got into minus 5 it is minus 0.495 minus 0.495 plus 0.05J. This is the equation for, this is the value of I3. So I now found the value of I1 and I3, but I want to find the value of VTH. Okay, so now I write the equation for VTH. So equation for VTH is, or this is basically equation for I2 if I2 is equal to 0. So in that case I1 and I3 are negative, right? So we have minus I1 into 10J. Okay, minus I1 into 10J. Then we have plus I2 into, and I2 is touching these two elements, that is 10J minus 5J, which is 10 10j minus 5j. That's right, I2 is touching only these two elements, right? And then what about I3? I3 is touching only this capacitor right here. So it's minus I3 into minus 5j, and then you have the voltage source VTH, not voltage source, sorry, potential, voltage potential VTH. So therefore I2 is flowing from the positive terminal to the negative terminal, sorry, from the positive from the higher potential to a lower potential. So therefore it is plus VTH is equal to 0. There's no voltage source anywhere over here, so it is equal to 0. So in that case, I know the value of I1, that is this value. I know that the value of I2, that is equal to 0, and I know the value of I3, that is equal to this value. Therefore I can find the value of VTH. So VTH is equal to I1 into 10j. I2 is 0, and this is minus of minus is plus, so it is minus I3 into 5j. This is the equation. Okay, this is the value of VTH. So therefore VTH is equal to I1 is 0.099 minus 0.01 j into 10j minus, and I3 is minus 0.495 plus 0.05j into 5j. So therefore this is equal to, now let me find the value. So we have here 0.099 minus 0.01 j into 10j minus, and here you have minus 0.495 plus 0.05 j into 5j. So you will get here as 0.35 plus 3.465j. 0.35 plus 3.465j. That is the value of VTH, or in polar form it is 3.483 angle 84.232 degree volt. This is the value of VTH. Okay, this is the value of VTH that you have got. So now I need to find the Norton's current. Okay, so to find IN, not only that, the question was to find the Norton's equivalent, right? So we need to find the value of IN also. So IN is basically the same circuit. IN is basically the same circuit. Okay, same circuit, but you need to short the two terminals. Okay, you need to join these two terminals. So which means let me redraw the circuit. We have a resistor over here, and then we have a triangle over here, we have a capacitor over here. This is 5i. Okay, this is minus 5j, and this is that inductor J10, and this is 100 ohm. This is I, and this is 10 angle 0 degree volt. And now I'm going to join these two terminals. Okay, I'm going to join these two terminals, that is A, B, right? I'm going to join these two terminals, and the current flowing from A to B is IN, which means I need to find the value of IN. Okay, but if I mark the mesh currents, this is I1, this is I2, let this be I2, and let this be I3. Okay, let this be I3. So now if you want to find IN, you need to find the value of I2, right? Because the current through this branch is IN, and also the current through the same branch is also called as I2. So therefore IN is equal to I2. So just simply find the value of I2 in this equation, okay, in this circuit. So there is a dependent source, right? 5I. So what is the value of I? What is the equation for I? Here I is the current through this branch, and the current through this branch is also called as I1. Therefore the equation for I is equal to I1. Now I write the equation for mesh 1. So the equation for mesh 1, okay, is I1 into 100 plus 10J, okay, minus I2 into 10J, minus I2 into 10J is equal to 10. This is the equation for mesh 1, right? Maybe I can, this whole thing is divisible by 10, right? So maybe I can just simply simplify this equation, right? There's no I3, I3 is not touching this element anywhere. So therefore I can say this is I1 into 10 plus J minus I2 into J is equal to 1, right? Dividing this whole equation by 10, I will get this equation, okay? So this is equation for mesh 1. Now I'm going to write the equation for mesh 2. Equation for mesh 2, okay, and here in equation mesh 2 means I1 and I3 are negative and I2 is positive. So minus I1 into, you have over here is 10J plus I2 into, this is 10J and this is minus 5J. So 10 minus 5 is 5. So we have 5J minus I3 into, that is also minus 5J, right? Minus 5J. There is no source, so this is equal to 0. Okay. Wow. Again also this whole thing is divisible by 5J, right? Wouldn't you agree? This whole thing is divisible by 5J. Let me rewrite the circuit. I1 into 10J plus I2 into 5J plus I3 into 5J is equal to 0. So this whole thing is divisible by 5J. So in that case it will become, this equation is minus, let me see, minus 2I1. Let me see, minus 2I1 plus I2 plus I3 is equal to 0. Plus I2 plus I3 is equal to 0. What do you want to find? You want to find the value of I2, right? Okay, anyway. So this is the value. This is the equation I got. Okay, this is a simple equation, right? Because this whole equation is divisible by 5J. That's why. So 10J by 5J is 2, 5J by 5J is 1, 5J by 5J is 1. That's how I got this equation. Now I'm going to write the equation for mesh 3. Equation for mesh 3, okay, and here the equation of mesh 3 is very simple because there's already a current source over there. The current through this branch is I3, right? I3 is the current that is flowing in this direction, right? I3 is the current that is flowing in this branch, and there's already a current source called as 5I in the opposite direction, which means basically this means that I3 is equal to minus 5I, right? I3 is equal to minus 5I. I3 is equal to minus 5I, okay? Or in other words, I3 is equal to, since I is equal to I1, I3 is equal to minus 5I1. There you go. I3 is equal to minus 5I1, okay? So simply substitute that over here. My job is to find the value of IN, but I know that I2 is equal to IN, so therefore I need to find the value of I2, and already the equation for I2 is already given over here. Simply substitute the value of I3 over here. I will get minus 2. That is what I meant is substituting. Hold on. Let this be. Let this be equation 1. Oh, I forgot to put I2 is equal to 0 over here, right? No, it's not I2. Sorry. What I said was stupid. This is what I know. So here I2 is not 0. So here's I2j. So we have here is I3 is equal to 7. So substitute equation. This is equation 1. I forgot to mark it. This is equation 1. So substitute equation 3 to equation 2. We get, so therefore what I get is minus 2i1 plus I2, and replacing I3 with minus 5i1 is equal to 0. This is the equation, okay? Or in other words, I2 is equal to 7i1, right? I2 is equal to 7i1. I2 is equal to 7i1. Let this be equation 4. So therefore, substituting equation 4 to equation 1. Okay, what is equation 1? I1 into 10 plus j, right? I1 is into 10 plus j minus I2 into j is equal to 1. Okay, this is the equation for, this is the first equation. So here I2 is equal to 7i1. So you have I1 into, let me see, 7i1. So this will become 7j. So this will become 10 plus 8j, right? I don't want to pretend. This is 10 plus 6j. It's 10 plus 6. Let me see. I1 into 10 plus j minus I1 into 7j. So it is minus 6j is equal to 1. Okay. So in that case, this will become I1 into 10 minus 6j is equal to 1. Or in other words, I1 is equal to 1 by 10 minus 6j. So therefore I'm not going to waste my time finding the value of I1, because I2 is equal to 7i1. So therefore I2 is equal to 7 by 10 by 6j. This is the value of I2. It is 0.515 plus 0.309j. Okay, or this is also equal to option converted to polar form, and you will get 0.6 angle 30.964 degrees amperes. This is the value of I2. So which means if this is I2, then the value of IN is also the same, right? IN is equal to 0.6 angle 30.964 degrees amperes. Okay, so therefore the value of ZTH, the value of ZTH is VTH by ITH, which is equal to, and your VTH is the value of VTH. It is 3.483, or I'll use the other one, 0.35. I don't want to use the polar form, I'll use the rectangular form. 0.35 plus 3.465j, 0.35 plus 3.465j divided by, and your IN, it's not VTH, it's not ITH, it's IN, right? And your IN is 0.515 plus 0.309j. Okay, so therefore Z, which means, let me find the value, 0.35 plus 3.465j divided by 0.515 plus 0.309 J. Okay, 0.515 plus 0.309 J. Here it is 0.35 plus 3.465 J. So here you get is 3.468 plus 4.647 J, which is in polar form it is 5.799. I'm tempted to write 5.8. Let me write 5.8. Angle 53.268 degrees ohms. Okay, this is the value of ZTH. Okay, so I found the ZTH. So what was the question, by the way? Question was to find the Norton's equivalent, right? So Norton's equivalent means simply draw the Norton's current and the Zn. So therefore it is, this is the current, this is In, this is the impedance, and Zn is equal to ZTH itself, which is 5.8 angle 53.268 degree ohms. Okay, this is the value of Zn. And In, the equation for In is, where is In? Yeah, 0.6 angle 30.964 degrees amperes. Okay, this is the Norton's equivalent.